students, in this video we'll show that the gamma of 1 by 2 is equal to root pi. We know that the gamma of n is defined by 2 times 0 to infinity e raised to minus x square x raised to 2n minus 1 dx. So here we are taking gamma of 1 by 2. So it is gamma of 1 by 2. Take n is equal to 1 by 2 here. So it will be 0 to infinity e raised to minus x square. If you put n equal to 1 by 2, it will be x raised to 0, which is equal to 1. So let me take another gamma 1 by 2 in terms of the function or the variable y. So it will be 0 to infinity e raised to minus y square dy. So multiply these two, it is gamma of 1 by 2 the whole square is equal to, it is 2 to 2 4, 0 to infinity e raised to minus x square dx into 0 to infinity e raised to minus y square dy. So combining these two integrals, it's 0 to infinity, 0 to infinity, adding the powers of e, it's x square plus y square dy dx. We'll solve this by converting into the polar coordinates. So the polar coordinates are given by x is equal to r cos theta and y is equal to r sin theta. The value of dy dx is equal to r dr d theta. Now when we convert the limits 0 to infinity, the x limits are 0 to infinity, the y limits are 0 to infinity. So the x limits are 0 to infinity, it means that the whole of the x-axis is considered and the y values are from 0 to infinity, means the whole of the y-axis is considered. So the region between the x-axis and the y-axis is the first quadrant. So the region of integration is the first quadrant. So in the first quadrant, the lower limit for r will be equal to 0. The highest value of r is infinity. So r varies from 0 to infinity and theta varies from 0 to pi by 2. Also note that x square plus y square is equal to r square. Substituting all these values in the given integral, it is gamma of 1 by 2 the whole square is equal to 4. The new limits are 0 to infinity for the r, 0 to pi by 2. It is e raised to minus r square r dr d theta. Now 4 will take the r function with its integral e raised to minus r square r into dr and into 0 to pi by 2 d theta. This we can do it if the limits are both the limits are the constant limits. Now to evaluate the first integral, so we will go for the substitution method. Substitute r square is equal to t. The derivative of r square is 2r dr is equal to dt. So r into dr will be equal to dt by 2. So therefore the integral e raised to minus r square r into dr will be e raised to minus t dt by 2. So that we can write the integration of e raised to minus t is e raised to minus t divided by minus 1. So we have taken e raised t as r square. So it is e raised to minus r square by minus 1. So the integration of 0 to infinity e raised to minus r square is e raised to minus r square divided by 1 by 2. So 1 by 2 is there minus 1. So that is between 0 to infinity. Integration of d theta is the theta. So theta between 0 to pi by 2. So it is 2 e raised to minus infinity by minus 1 minus e raised to 0 by minus 1. Here it is pi by 2 minus 0. So e raised to minus infinity is 0 and this one e raised to 0 is 1 minus minus plus. So it is 2 into pi by 2. So the 2 and 2 get cancelled. So therefore gamma of 1 by 2 the whole square is equal to pi. So we can write gamma of 1 by 2 is equal to root of pi. Thank you for watching.